In this series of videos I'm attempting to repair and restore this ASR33 teletype. In the series so far I've completely dismantled the unit, cleaned the various sub-assemblies, carried out some repairs. I've now reassembled it. As you can see, the keyboard is working, electronics pack's working, the tape reader, punch, all working. But I've still got a minor issue with it. It will print fine 99% of the time, but every now and again it will throw in a rogue character. So if I press the H key, for example, it will print an H, but if I press the L key it might print an @ sign or something. But most of the time if I run through the character set it prints it fine. So what I thought I would do in this video is go through how I go about tracking down a fault like this. As I say, it's working fine most of the time, but now and again it throws in a rogue character, so it's fairly intermittent, which makes it quite difficult to track down a fault like this. There are some techniques you can use, and I thought I'd show one of them in this video. It is a very good technique to use on a machine like this, and in fact is something that is an invaluable technique and will save you a lot of time. One of the problems with a machine like this is if you get a rogue character printing, there's many sources where that error could come from, and so the best way to approach this is in a logical sequential manner. And so what I'm going to do next is just very quickly go through the general system operation, and that will help us to track down what is causing this problem. So to begin with, if we look at the character set and the print head specification for this machine, so we've got the print head up here, and the way this machine works is if you select a particular character to print, whether that data comes from the serial input, whether it comes from the keyboard, or whether it comes from the tape reader, the machine works in fundamentally the same way. There are a series of code bars down here, and those code bars are set depending on the character that's going to be printed, and those code bars determine how to position the print head. So if you imagine unrolling this print head, it's on a cylinder of course, but if you unroll that cylinder you end up with this. And looking at this, the print head is arranged as if though this is wrapped around, and if we rotate this counterclockwise, which is kind of this direction looking from the top, then we rotate the characters on the right hand side from the center point into position, and we're trying to position the characters in this imaginary square at the top. And if we rotate the cylinder clockwise from the top, then we are rotating the characters on this side into position. What we then do is raise the print head by the required amount to select the row that we want. So what tends to happen here is, you'll probably notice if you've worked on one of these, that initially when you start getting problems like this, characters like H will work fine, A will work fine, 1 will work, 8, Q, P, X will work fine. If you try something like F or E or 6 or W, then they won't print. And that's not that unusual, and it gets worse as you get down the rows, and that's because the if it's something sticking, then obviously it has to move far further to print as we get towards the extremities. And in fact you might find that only characters from one of the center columns will print. But we can track down where the problem might lie. If we look at the character set, it's quite easy to decode this. So if we take a character and we start looking at the individual bits, then each of these bits is ultimately responsible for setting one of the selection parameters. So if, for example, we take the top row here, then the top row, we look at the first 3 bits, bit 1, 2 and 3, all 0, and then if we look at the characters, we notice that the characters are P, at, 0 and space. If we then look at the print head, notice that we've got P, 0, at and space. In other words, the resting position for the print head is in the center line, and so moving it to this column or this column is effectively the zero value for movement or rotation. If we look at the next line down, where the first bit is a 1, notice we have the exclamation mark, 1, A and Q. Notice here, exclamation mark, A, 1 and Q. And if we go the other way, we'll have open close brace I, 9 and Y. And looking back on here, if you follow this down to where this bit is a 1 again, notice that we have the exact same sequence. In other words, bit 1 is responsible on its own for positioning the column 1. So we have column 0, column 1. In fact, the first 3 bits in the character set determine how far we want to rotate the print head. And if you want to look at the values on here, so I'll put these on if you want to pause and have a look at this, then you'll notice that as the values increment, then so we get further out. So if we look, for example, at the look at G. So if we look at character G, then look across at the first 3 bits, they're all 1s, and that's because that's as far as we can move, and the F will be, of course, 1 less, so we're getting 1, 1, 0. So in other words, bits 1, 2 and 3 determine how far we rotate the head. We then need another bit to determine which direction to rotate the head. So if we look at G again, and then look at bit 4, notice it's a 0, and that's because we are rotating in this direction. If we look at 7, then again the bit 4 is 0. But if we go the other way and look, for example, at N, and then find N on the character set, then we can see that the bit is in fact set to 1. And it's the same for all the characters. If we take another one on the right hand side, L, it doesn't matter how far, as long as we're going right, L for example, if we find character L, then we can see again that that bit is indeed a 1. And it's the same for all the characters on this side of this table. This bit will be 1, and all the characters on this side, this bit will be 0. So in other words, this bit 4 is the direction bit, and that just leaves the height. So there are 2 bits for the height, and that's the next 2 bits up, of course. And first thing to determine, of course, is the correct value coming from the keyboard. So we'll start with the keyboard. I did show roughly how to do this in a previous video by connecting a scope and a current clamp to the solenoid, and then you can capture the data on a scope. I've actually done this already, and the data is always correct even when it prints the wrong character, but I thought we'd just recap and have a quick look at this. Now, anyone that's worked on one of these machines for any length of time, or if you've worked on a number of them, I work on a lot of these, so I've tended to make up special tools, and I'm sure that everyone else who works on these does something similar. So I've dug out the tool I use for carrying out this sort of testing. What I want to be able to do is rotate the machine slowly, so I can observe what's going on, look at the mechanics as it's rotating, and possibly also measure the signals coming out of the keyboard or from the reader. But the problem we have with this is we need the machine to be powered up for this to work, because the solenoid and the electronics has to work. But if we power up the machine normally, then it's just going to start spinning at high speed, and we can't control this. What we can do, however, if I just rotate this around a bit, is we can take the fuse out of the motor drive. So if we just pop this fuse out, put the cap back on because that contact is live, but with that fuse out we can now power the machine up. Everything else will work, but the motor will not spin. However, I need to be able to rotate the machine, and that's where this comes in. So I made this tool quite some time ago, but it is extremely useful. And this technique can be used not just on the ASR33, but any mechanical teletype. And this, of course, is used to rotate the motor. So the way this works is, it take the original knob, this then fits onto the tool, and then this slots onto the motor shaft. So the motor shaft, of course, is just in there, and then what I can do is I can now use this to rotate the machine slowly, and if we power it up, the motor will not start up, but everything else will work. So what we can do is I'll reposition the camera. I'm going to have to move the camera around quite a lot as I show this, but we're going to go through an entire print cycle and see exactly how the machine works. So I'm just going to turn the machine around, and we'll start by looking at the keyboard switch settings. So we're looking at the switches on the end of the keyboard, and this is obviously where we start. We could start with a tape reader or serial input, but this is by far the easiest way of doing this. And if you recall, the bits are ordered on this particular keyboard. This is a non-parity keyboard, so we have bit 1, we skip the next one because that's shift, so 1, 2, 3, 4, 5, 6, 7, and they're the bits in effect that we need to look at, and they should correspond to the bits on the character set. Now I want to use or select a character that's kind of halfway out or so in terms of rotation, and so I'm going to choose the character 5. You can choose whatever you want, of course, and then just make sure that you're getting the expected results. So what we expect to see if we press the 5 key on the keyboard is we should get the switches set 1 0 1 0 1 1 0. It'd be hard to actually demonstrate this, but when I press the 5 key, the switches should all set in that mode, and also this lever at the back, that's the one that's connected to the H-link at the rear of the keyboard, should move up, should pop up. You won't be able to see it, but you should be able to hear it. So I'm going to press the 5 key now. Okay, so the lever did in fact pop up. You could hear it click. It's now at the top of its travel, and if we look at the switches, we can see which ones are open and which ones are closed. And although you won't want to see it here, you can get a test meter if you're actually testing one of these and make sure you get the expected settings. Now I know this works, I've tested this and it all works fine. So once we do this, then the machine's powered off at the moment, but once we've got the keyboard giving us the correct contact settings, the next thing to do is check that the distributor is giving us the right value. So I'm just going to quickly move the camera and we'll recap on how that works. Okay, so the distributor sits on the end of the secondary shaft, and this is a simple representation of the keyboard, which is this set of switches down here, and then the distributor. And the way this works is extremely simple. There are just 2 wires in effect, and the switches on the keyboard determine which of the paths will conduct. So each of these switches represents one of those spring contact switches we just looked at, and in our case we should get exactly the same pattern that we're seeing for our number 5 key. As the machine spins, once the key's been pressed, when you press the key and that lever on the H-link goes down, it enables the print cycle, and this will then start to spin. It's divided on its outer perimeter into segments, and each one of those segments is connected to one of the switches. There's this inner slip ring that goes all the way around, and then there's a sprung brush system which is on that plastic 3-pronged rotor that we can see. And all that happens is as this turns, it moves round and it sequentially connects each of the outer segments to the inner slip ring, and if the switch connected to that particular segment is closed, it completes the loop. So in other words, if we're at this position, for example, and the switch is actually closed, we'll get a conductive path from B through this switch, through this segment, through the brushes, to the slip ring, and out through A. So there will be a direct contact between these 2. If the switch is open, then of course it will not give us a conductive path. It will then move round to the next segment, and if the switch connected to that segment is closed, again we'll get a closed loop, and if that's open, we'll get an open loop. and the same for all the switches. So effectively it's scanning all the switches on the keyboard. Any switches that are closed on the keyboard will give us a conductive path. The loop will be closed. Any switches that are open, the loop will be open. This should also give a hint as to how this communicates with remote machines, in that there's another one of these on the other end of the long wire, the telegraph wire or whatever, and it's just looking at exactly the same thing, and there's normally a current flowing through here, hence the current loop system. Okay, so what we would normally do, or what we could do, is check that the data coming out of this is correct as we rotate the machine. You can put a multimeter across this with the machine powered off. It will still go through this process with the machine powered off. You can just rotate it manually. It won't operate the solenoid, of course, but you can put a multimeter across these 2 points, rotate the machine, and make sure you get the expected code sequence based on the key that you pressed. I've tested that, it works fine. This system is connected to the little electronic board on the electronics pack, and that is used to take the signal coming through this, and it drives the solenoid. So it will turn the solenoid on or off depending on the state of the particular switch it's scanning at any moment from the keyboard. So the next question is, well, okay, it's scanning this, and at any instant in time the particular key state on the keyboard is known, but how does it correlate that with the mechanical position of the printer mechanism? So I'll move the camera again and we'll just explain how this relative timing works. So we're now looking at the rear of the machine. This is on the end of the main shaft, and we can see there are a series of cams, and they will rotate as the main shaft rotates. Each of the cams, and there's one cam for each of the bits, and there is one bit for each of the code bars, and as these cams rotate you'll notice that each one has got a small cutout in it, and the cutouts are staggered, so they basically move around in sequence. If we start with the first cam, when the cutout on this cam lines up with its cam follower, which are these levers we can see at the bottom, then that would allow the cam follower to raise. But whether it raises or not is dependent on the position of the solenoid. So in other words, these cutouts in the cams are the sample points for a particular bit. So when the cutout on the first cam, for example, is adjacent to its cam follower, then that should occur at the same point as the distributor is sampling that particular switch. So in other words, when bit 0 is being sampled, the cutout in the bit 0 cam must be adjacent to the cam follower. At that point, if the switch is open or closed on the keyboard, and that's what's being sampled, of course, the solenoid will either energize or de-energize, and that will either allow the cam follower to rise or not allow the cam follower to rise. So in other words, this mechanism is being used to turn the electrical state of the switches on the keyboard into the mechanical position of the cam followers. We have this mechanism here, and they refer to it as the rangefinder in the manual, and the reason they call it that is because it sets the operational range of the machine. And what it's for is to set the relative timing of these detents in the cams with the rotational position of the distributor, and it's to make sure that it's effectively sampling the electrical switches on the keyboard at the correct time relative to the position of the mechanics. And they call it a rangefinder because the way you adjust this is you loosen the screw, you move it one way until you start getting errors in the printing, you then move it the other way until you get errors in the printing, and then you set it in the center portion of that range, hence rangefinder. So once the machine has done a full cycle, it would in theory have set all the cam followers into positions determined by the state of the switches on the keyboard. I'll just rotate the machine round again. So as each of the cam followers is allowed to rise or not rise, it will change or not change the position of one of these code bar control levers. And depending on whether these rise or don't rise, it will determine whether a particular code bar is allowed to move later in the cycle or whether it will be blocked from moving. Okay, so the outcome of this sampling is to set these control levers into the required positions. So I'll turn the machine around and we'll look at the code bars. So these are the code bars, and if the control lever for a particular code bar is in the raised position, then the particular code bar will be allowed to move to the left. Moving to the left is a kind of a ramp towards the extreme left and extreme right, so if it moves to the left it will also rise. It only moves under spring tension, so it's not actually directly driven, it's just effectively released by the control lever being moved out of the way, and then these fairly small springs are used to pull the code bars across. As they move across they rise, and depending on which ones are selected you end up with some code bars raised and some not raised. They're used to control the functions within the print head, so I'll just move the camera once more. Okay, you probably can't see them, but this is the print control mechanism, print head mechanism, and then there's a series of white plastic followers that run along the code bars, and they are used to connect to the print head mechanism, and when they will detect whether the particular code bars are raised or not raised. They don't directly drive the print head, but they will set stops for its height and they will set stops for its rotation and direction. And so depending on the code that is on the code bars, that will determine how far and in what direction the print head will rotate, and that determines which character will be printed. And there are other parts of the mechanism, for example this part here is used to build up some spring tension and cause the hammer to impact the print head, which is what causes it to print through the ribbon. Okay, so what we're going to do now is run this through a full cycle and see where the fault lies. I might have to do this several times because it's, as I say, it's intermittent, it doesn't always show the fault. But what we're going to do is start by powering up the machine. I'll just move the camera back and we can start to see what's going on. Okay, well if you recall I pressed key 5, so we've got that value encoded on the keyboard switches. I'm now going to power up the printer. It won't start up the motor of course because I've removed the fuse, but it will still power up the electronics. So we're now powered up and ready to go, so I can start to rotate the machine. I'm just going to reposition the camera so you can see the distributor rotor, and you'll see it starting to turn. Okay, so we have the distributor rotor here, and if I now start to rotate the machine, you should see that begin to rotate. Okay, so it's starting to turn. I won't go any further than that just now, but it's starting to turn, so the print cycle has been started, and the print cycle has started because we pressed the key, the H lever rocked and enabled the mechanics. So I'm going to move the camera now so that we can see the left hand side of the machine, and in particular we want to observe the solenoid. Okay, so looking at the end of the main shaft, we have the solenoid armature here. You can see the edge of it. We're looking kind of edge onto it, and also notice that the main clutch at this end of the main shaft has disengaged, so it's started to rotate. Now as I rotate the motor, what we're going to see is the other end, the distributor is going to start to rotate. That's going to sample, or allow us to sample the state of the keyboard switches. That in turn is going to be used by the small control board to control the solenoid, and we should see the result by movement of this armature. So I'll turn it fairly slowly, but you should be able to hear the the solenoid click in and out, and you may be able to see the armature moving. So it's just moved. By moving, it's going to either allow or disallow one of the cam followers to move up into its raised position, and that in turn will allow one of the code selection control levers to raise or lower. So we'll move on now. As we rotate, we'll go on to the next bit. And you can see we've now moved on to a different bit. If the bit was the same, if it was a 1 followed by a 1 or a 0 followed by a 0, then of course the solenoid wouldn't change state. But what we're going to be doing here is working through the bit sequence required for the key that we've pressed, which in this case is a 5. So as I continue to rotate, we've now selected the next bit. We'll keep going, another bit, and by looking at how the solenoid is moving, we can check whether the switches are being properly sampled, whether the solenoid is working, and also whether the correct bits are being selected in the control levers. Okay, so we're now getting to the point where we've sampled all the data, and we can now see the control levers starting to come up. So I'm going to reposition the camera and we'll watch the code bars. So as I continue to rotate the machine, we're at the point now where the code bars are about to be released. The ones that have been selected should move to the left and up, and the ones that are still blocked should stay down. So I'll continue to rotate the machine. We can see the code bars are now starting to move. Okay, so we've got the code bars in their raised positions. Now at this point we need to try and determine if the correct code bars have been raised. And so what you can do is very carefully, remember this is switched on, is make sure that any that are blocked are properly blocked, so no more should move. That one wasn't moved up properly, so the second one back, the third one back was sticking. We'll continue to rotate the machine. So all the code bars are now up. I'm just going to move the camera across a little bit so that you can see the print head. And so power is now being supplied to the print head, and exactly what it does will be dependent on what the setting of the individual code bars is. So you can see the head is now rotating. Also keep an eye on the hammer. I'll move the camera across a bit further. So also keep an eye on the hammer, which is down here, and once the head's moved into position, the hammer will be released and it should impact the head and print the character. So we can see the head is now rising, so it's rotated as far as it's going to. And we saw the hammer impact the head, and we'll now just finish off the cycle, and towards the end of the cycle all the code bars will be pushed back down, which is now what's happening. The hammer will be pulled back, the carriage will move across, and that's the end of the cycle. However, notice that the wrong character is printed. I pushed key 5, but it's printed an H. So looking at the character set, we can see that it did not rise and it did not rotate correctly. Now I'm going to run this through again. We'll try and see what happens, and it looks like one of the code bars is sticking. So we notice one of the code bars was kind of jammed up and it hadn't moved. I'm just going to run the machine back through a cycle. I'm not going to reposition the camera. I'm just going to press key 5. So I've pressed key 5, I'm starting to rotate the machine. We'll hear the solenoid clicking in and out, and then eventually we should see the code bars start to move. So the code bars are now starting to move across. And I can now see what the problem is. I'm just going to move the camera across. Okay, all the code bars should have moved into their ready to print position. But notice one of them is only halfway across. I don't know if you can see it very clearly, but this one, towards where the tip of the screwdriver is, it shouldn't move any further. If I touch it, notice it then moved up. So that should have moved on its own. It's obviously sticking. If we carry on rotating, complete the print, it should now print the correct character. You can see the print head. If you can't see the print head, I'll just move this back across. Okay, the print head has moved much further this time. It's gone up higher. It should now impact, which it has done. We'll finish off the print cycle. Going to now finish off, and this time it's printed the correct character, so it's printed a 5 because I manually moved the code bar across. I'm going to try it again and see if it sticks. If it sticks this time, I won't free it up and we'll see what it prints. I'm going to press key 5, which I have done. I'm now rotating the machine again. You'll hear the solenoid clunking in and out, and eventually we should see the code bars start to rise. Okay, and once again, if we just move the camera, so once again that code bar, so it's the third one from the back, is only halfway up. I'll turn the camera back round so you can see the print head. I'll continue to rotate the machine. The head is moving. It's impacted the print head, and it has printed the right character, but it's kind of offset, so I think it was just far enough to print. I'm going to try it one more time. I'm not going to move the camera this time, I'm just going to press the same key, go around. Okay, the code bars are starting to rise. Our row code bar is in its stuck position again. In fact, the second one from the back is also sticking. We'll wait until it finishes printing. Notice that the head is not rotated properly. Okay, and this time, I'm not sure if you can see it or not, it's printed a 1 instead of a 5. If we look back at the, if I move the camera back so you can see a bit of a wider view. Okay, so I'm not sure if you can see the character or not. I'll just try dimming this light. Okay, but it's printed a 1 where it should have printed a 5. And if we look on our head map, you can see it just hasn't rotated far enough, and the particular code bar in question is the one that determines how far this is supposed to move, so that would tend to make sense. Now I know it's not the code bar itself that's sticking. I've freed all those off and they move freely, so what's sticking is what's inside the print head, the carriage itself. So I'm going to try and free that off, and the easiest way of doing that is to drive the machine to the point where the code bars are supposed to have moved, stop rotating it, and then you can move the code bar back and forth and see what's sticking. Lubricate it, clean it, whatever, and then it should start working. Okay, so I spent some time freeing up the levers in the carriage. It now seems to be printing correctly, so I can go through the entire character set. I've done this a few times and it seems now to be giving us the correct characters. Someone wanted to see the print head up close printing, so I'll just quickly show that before I finish the video. but all I'm going to do now is run this machine through some tests, and then other than the case, it is pretty much complete.